In this lesson, we're going to be solving a couple of problems from page 472. The problems that we're going to be solving are solving right triangles. So for problem number 8, we're given that uppercase A is 7.4 degrees and lowercase a is 20.5. There's no units on here, so we're kind of off the hook. So how is this a right triangle? So common practice, let's go ahead and draw a right triangle. Common practice to label a right triangle is to have uppercase letters represent the angles. So I'll do uppercase A, uppercase B to indicate each of these angles. In common practice, uppercase C is typically going to be your 90-degree angle. We use lowercase letters to represent side lengths across from those angles. So across from angle A, I would have lowercase a to represent the side length here. Across from angle B, I would use lowercase b, and across from uppercase C, I would use lowercase c for the length of the hypotenuse. All right, so here's our correctly labeled right triangle. These are the pieces of information I'm given. So if we want to, I might come over here and just write in 7.4 degrees. And then side A is 20.5, so A equals 20.5. Okay, so solve a right triangle means to find all missing sides and angles. So kind of first what I do is I kind of label my triangle, and then I'm aware of what's missing. I kind of work with the angles first. So I know angle A. I do not know angle B, so I'm going to put an uppercase B with a blank, knowing that that's what I have to find. Okay, uppercase C is always 90 degrees. So I won't record that because I have that information. So now let me deal with the side length. So do I have lowercase a? Yes, I do. Do I have the length of side B? No, I don't. So I'll put lowercase b. And I do not know the length of the hypotenuse or lowercase c. All right, and then I just plan my strategy. Based on the information given, how am I going to find some of this information? I think actually what I'm going to start with is finding the missing angle. Since I know C is 90 and A is 7.4, and all three angles in a triangle add to 180, I'm going to do 180 minus. I'll do an open parentheses so that I can add the 90 plus the 7.4. So angle B measures 82.6 degrees. Of course, my triangle isn't drawn to scale, but that's okay. All right, if you knew that you didn't need to add 90 and 7.4, of course, if angle C's measure is 90, the sum of these two angles have to be the other 90. So I could have simply just taken 90 and subtracted 7.4 and still gotten 82.6 degrees. Don't forget your degree symbol. All right, let's find, I'll find B next, I suppose. All right, how am I going to find side length B? Let me go ahead and label this. Well, I'm going to use a trig ratio. All right, so if I need to find lowercase b and I have the angle across from it, then I also have side length A. I'm thinking, okay, what trig ratio involves opposite and adjacent? So I'm going to put over here, find lowercase b. To do that, I could take the tangent of 82.6 degrees and set that equal to B over adjacent 20.5. In order for me to find B, I'd probably, since this is a proportion, I would probably do cross multiplication. Notice how easy this becomes then. It's B equals, I would put the 20.5 up front of the trig function, because if you put it behind here, you might want to, you might end up accidentally multiplying 82.6 times 20.5, and that's not what we want to do. All right, I'll go to my calculator. I'm going to make sure that I'm in degree mode first, which I'm not. And since I'm about to enter an angle and find a trig ratio of it, or a trig value of it, I need to put it in the correct mode. So make sure you're in degree mode. And I get 157.841. I'll round to 3 decimal places, and I'll record it over here. Okay, so next I need to find C, and that's the last thing I need to find. All right, you got a couple of options. You can use another trig ratio, or because you have two side lengths, you can use Pythagorean Theorem. So since I have A and B, I can use Pythagorean Theorem and find C. So you have a calculator, so you could pretty much do that quick work on the calculator. You could also set up a trig ratio if you want and get the same answer. If I want to find C, then I think about having, I choose one of the angles. I think about having angle B, and a trig ratio with the adjacent and the hypotenuse would be cosine. So I could do cosine of 82.6 degrees equals A over, or 20.5, if you will, over C. So it just really becomes a personal preference. Do you want to do Pythagorean Theorem, or do you want to do a trig ratio? Either one of those requires some evidence of your work. So if you're going to do Pythagorean Theorem, make sure and set it up before you let the calculator get your answer. All right, cross multiply. I'd put the C up front. So C times cosine 82.6 degrees equals 20.5. All right, to get C by itself, I need to divide both sides by cosine of 82.6 degrees. Those will cancel. So come here, do a fraction, cosine 82.6, looks good. So 3 decimals. I just do a real quick last inspection. If this is a right triangle, then I know C, my side length C, has to be the longest side, and this value of C here is definitely larger than either lowercase a or lowercase b. All right, let's do 12. All right, we're going to be solving a right triangle, so I'm going to get that drawn. Angle A, angle B, and of course angle C. Side length A is over here. I don't know what that is. Side length B is across from angle B, and I do know that's 1.32. Side length C is across from angle C, and I do know that's 18.9. Okay, what do I need to find? Well, I need to find angle A, and I need to find angle B. And let's see, I need to find side A. Okay, so let's see. I'm probably going to use an inverse function to find an angle. So I don't know either angle A or B. I think if you want to find angle A first, that's fine. Put yourself up here and think about, I have the adjacent side and I have the hypotenuse. So what trig function is adjacent over hypotenuse? Well, it's going to be cosine. So I'm going to tell myself over here I'm finding uppercase A, and how I'm going to do that is I'm going to use cosine of angle A is equal to adjacent over hypotenuse. Okay, so how do I find angle A? Well, I bring in the arc cosine, or the inverse cosine, to both sides of the equation. So angle A is equal to arc cosine of this value. So let's go right to our calculator. Arc cosine and a fraction. That looks about right. All right. So remember, you're in degree mode, so that's 85.995 degrees. Hopefully I'm still on, yeah. So 85.995 degrees. So now to find angle B, I'm just going to take 90 degrees and subtract angle A. As a matter of fact, I'm just going to be kind of efficient here and just hit minus 90 And I'm just going to record the positive value because it would be 90 minus what I had, but I already had that in there. So this was just quick for me. So the angle measure is going to be 4.005 degrees. Well, that's a real small angle. That's definitely not drawn to scale, but that's okay. All right, and all we have to do is find side A. Well, I guess you could use Pythagorean Theorem. So let's find lowercase a. If you want to do Pythagorean Theorem, I would do a squared plus b squared equals c squared. So there has to be some kind of evidence of how you found each of these missing angles or sides. So a squared is equal to 18.9 squared minus 1.32 squared, if I just move this over. And I'll just go right to my answer. I know A is going to be the square root of this answer. So I'll bring in my square root symbol. .854. No degrees, I'm finding a side length. All right. Let's take a look at 18. It has a little bit different twist to it. Nothing we can't handle though. Let's see, I think I can fit it on here. We're cycling back in the degree, minute, second notation. And then we do have units for a side length. All right, if we were to go to the textbook and read this problem, it's different than 8 and 12. What they gave us is an isosceles triangle. Isosceles meaning two sides the same. They gave us this. This is what's given. And they told us that theta is here and that theta is also here. So if this angle measure and this angle measure are the same, then the sides across from them are the same. That means that this is an isosceles triangle. They also told us that B, so this was A and this was C. So we're not dealing with a right triangle here yet. Okay, and this was angle B. Across from angle B, this side length, lowercase b, is 3.1 centimeters. Okay, and the question asks us to find the height of this isosceles triangle. So that would be this distance right here. Well, when you draw this altitude from angle B down to the opposite side, you're creating two right triangles. And just kind of background information that we had to kind of pull from. All right, so now we're dealing with right triangles like we've been dealing with. So what happens to the distance from here to here? Well, because we have, this is a perpendicular bisector right here. It bisects this. Let's find half of 3.1 on the calculator. All right, so each measure of this side right here, if we cut it into two equal parts, is 1.55 centimeters. So that's 1.55, and this is 1.55 centimeters. Okay, so that's all given. Okay, so now the objective is to find this side length, this height. So I think I'll just call it X. I'm not going to use the A, B, and C here. Let's call it X. Well, I guess it's really lowercase a. Well, I'll just call it X. Okay, so let's think about what we have. We have an angle measure, and we also have the adjacent side to it. And we want to know what is the opposite side length. So adjacent and hypotenuse, or excuse me, adjacent and opposite. So from this angle, I'd go opposite over adjacent. I'm going to set up a trig ratio with tangent. So the tangent of theta is equal to X over 1.55. In order for me to find X, I'll just put this trig ratio or trig function over 1. I'll do cross multiplication. I'll put the 1.55 up front. And I'll get an answer to 3 decimal places. let's see, degrees. Degree symbol, since I'm going to use degrees, minutes, and seconds. Where's that angle key? There it is, above apps. 23, second apps, and 45. But the seconds is the green key above the plus key down here on your calculator. So to get that, I'll have to hit the green and the plus key. Close my parentheses. Do I have everything? I think so. There we go. So the height of that isosceles trapezoid to 3 places is 2.964. Units, yes, we did on this problem. I think it was centimeters. Yep. So that's our answer. All right, so using trig ratios and inverse trig ratios to help us solve triangles, solve right triangles.